I'd like to first thanks to the Open Source India to providing me an opportunity to talk on this platform. So I'm really glad for that. So a little intro about myself. So myself, Patru, and I have close to 12 years of experience in the technology field. So mostly I love coding. So most of my 12 years has been active coding. So today, or the currently I'm part of Lowe's India as a lead engineer. And the topic which I like to present, it's all from my own learning. So it's about microservices, a modernization journey. And so this all talks is on my own learning. So a disclaimer. So I'm not talking behalf of Lowe's or anything. It's all my own personal learning on the what I have done and what the industry practices are in this microservices. So I'll be talking about those. So why I'm calling it a modernization journey, right? So because this journey provides an opportunity to modernize, and that's the whole reason I'm calling it a modernization journey. And what the microservice architecture itself provides that opportunity to modernize. So it's an opportunity to modernize the technology. So a lot of time, uh, the industry's technology space is moving very fast. So it's provides that opportunity to get to the pace of that technology. It's provide the opportunity to the way we are delivering software today, right? It's provide that opportunity to adopt those modern way of delivering software. It's provide that opportunity to adopt a new team culture, means modernizing your team culture. It's provides again the opportunity to relook our existing business processes to enhance it, to modernize our business processes. Again, it provides the opportunity to modernize the customer experience, the capability to add new capability with great speed, improve customer experience. So these are the opportunities what it provides to modernize, and that's the whole reason I'm calling it a modernization journey. But why journey? Okay, so let's try to understand why it's a journey. So it's a journey to transform the monolith. So it's not about the business are not doing their operations today, but it's all about how they used to do and how they can modernize uh, things, transform from your monolith to microservices, so that they can explore this opportunity to modernize. So why then a journey, right? It can be done as a big bang. So my monolith is working, I can rewrite everything, and next day I go ahead and deploy my new code and I'm done. So I'm calling it a journey. So I'm quoting here is a famous quote by Martin Fowler. So I'm a big fan of this guy. He writes a lot of very good stuff on the design principles and things like that. So if you do a big bang rewrite, right? The only thing you are guaranteed of is a big bang. So that's what he was trying to say. So what I understood, so these things cannot be done overnight or within a month, or sometimes could not be even possible within a year, right? So but we can definitely achieve it to if we think it's a journey. It's a journey, and someday we'll achieve it, right? So with that mindset, let's move forward. So why I'm talking this, like what this microservices is, I think by this point, after covering through 3 slides, this question must be striking in our mind, because my topic name was microservices, the modernization journey, right? So what are the microservices are? So there are a lot of definitions of microservices, and everyone will have their own definition of microservices. But I like the most, which is told by the Sam Newman. He's again a great guy. Talks about all these microservices principles. So I took his, and what he is saying, microservices are independently deployable services. This is a main piece: independently deployable services around a business domain, and they communicate with each other via networks, and that's what the microservices is as per Newman and I. So and this is the one of the great definition what he has came up with. So let's try to explore what this independently deployable service and business domain, what I'm talking about. So it's necessary to align the microservices with a domain bounded context, right? So even before I'm talking about uh, going deeper to microservices and trying to understand that, there is a monolith which is there most of the companies, most of the big organizations, but why not just stick with that or develop new monoliths, right? So what's wrong with that? You might have a question that after hearing, okay, we're talking about microservices. So what exactly microservices? I mean, it's all functionality of business live together, a single deployment. So if you talk about a retail system, your payment, your checkout, your UI, and your order system, everything is tangled together in a big piece, and you go and deploy that, right? So that's a monolith. So the problem with that, what the people face or the developer face, right? Longer change cycle because it's a big monolith. If you want to do a smaller change also, you have to coordinate with everyone, so it makes the release cycle longer. Hard to maintain modularity because it's very hard in a single code base. I mean, there are a lot of organizations have successfully done it with a modular monolith, what they call it, but it's a little tough to draw those lines to create those separations, right? And scaling all or none, and that's also that. So some part of monolith if required a scaling because that particular module needs some more resource, but that's not possible. You have to actually scale everything, or you scale none, right? So that's what the monolith is, because just it's just a one a big process which is running. uh, and then confused lines of ownership, right? So it's very hard to define those ownerships in a big code, right? And it's always those gray areas will be there, or those gray space will be there where the multiple ownerships will be there. So that also creates those confusion, who actually owns that piece of code, and sometimes the change come to that piece, and then it's a very uh, uh, tough or longer process goes through. But with all saying that, the challenge is there are advantages also with a monolith. It's not like the monolith doesn't bring any advantage, right? So it's avoid deployment pitfalls of a distributed systems, right? With a simpler deployment topology, because it's just one application. I just have to take care of that its deployment, and I don't have to deal with a lot of network connections. Because when I talk about microservices, so they have to communicate through networks, right? Via either the option like HTTP or the messaging, but they have to talk. But with monolith, okay, we have that luxury, everything sitting together. So your workflow, your monitoring, troubleshooting, testing could all be comparatively simpler because it's one code. So code reuse also one of the biggest advantage of monolith, but still there are the challenges which I have highlighted, right? So that's the debatable. So monolith versus microservices are choice based on circumstances. So it's not like monolith is bad, microservice is good. So it's all about what your business circumstances and business need and business priorities are. So moving to that, so this is the famous three tier architecture, right? Where you'll have UI, and in between you have a backend services, and then at that your database, and your team also will be segregated based on that. You'll have a UI team separately, you have a backend team, and then you'll have a DBAs, right? And so there is a famous Conway law is there, which has been written by Melvin Conway, and what that law talks, why this monolith came into picture even before the microservices came, right? Because what as per the Conway's laws, organizations which design systems are constrained to produce the designs which are nothing but copies of the communication structure of these organizations, right? So because the teams are aligned like that, and the design also evolved similar way. Okay, UI guy, you develop UI, backend folks, you know backend well, group together, you guys develop backend, and the DBAs are the expert to manage the database. And because the communication structure is like that, the design also evolved like that. That's what the Conway's law says. If I so let's say if I try to apply the same Conway law in microservices, right? So that's one of the principle of microservices architecture, aligned to business capabilities or domain. So now if I have a team which is aligned to business capabilities rather than focusing on the UI guy and the backend guy, so the single team will have the UI experts, the database experts, and the backend experts, right? So now I'm aligning to business capability. So a price could be its own domain. Your payment could be its own domain, right? Your item could be its own domain, things like that, right? So that's again because of Conway's law. So if my organization, if I structure in a domain way, your design also will be aligned to business capabilities. And the second biggest principle of microservice architecture, as per me, is independent deployable. And if you remember that, I was mentioned in my definition also. the independent deployable means changes can be deployed to production without dependent on other services. Means we should have a stable contract between services and loosely coupled, well-defined service boundaries. So along with it, the product should own the full life cycle of it, right? So you build it, you run it. So that's the famous Amazon way of working, which initially started, and a lot of other organizations also adopted it. That means a single ownership, a complete ownership, starting from development, coding, building, deploying, and even after deployment, the support it, right? So that also uh, is one of the principle or the characteristics of the microservices architecture. And then after that, own your data, and that's also a big piece when I talk about the microservices architecture. So decentralized data based on the bounded context. So what I mean by own data and the decentralized data, right? So let's say uh, idea of microservice is not about to sharing a database, right? We can in extreme scenarios where it's not even possible to decouple those data, but the idea is not to share the database. And if it's need data held by another service, then ask for it. Ask to that service, hey, give me this data. So this pattern helps to create those bounded contexts which I'm talking about, create those domain boundaries, well-defined domain boundaries, which service own what data, and it's essential to achieve this independent deployable. So if you see, the independent deployable is very much related with owning your data and decentralize your data based on those the boundaries. And this is oops, sorry, this is one of my favorite principle I feel. So it's like as decoupled and as cohesive as possible. So if I have to explain the coupling, so coupling means like how changing one thing can impact the another, right? So that's what this coupling is, and we have to be as low as on coupling, so that one change should not impact the other. And similarly, the cohesion, right? So cohesion is about how we can group the related code together. So that's all about cohesion, like the code which change together should stay together, and that's what you can talk, and that's you might hear a lot of time the definition of cohesive, right? So again, I have put a quote from Larry Constantine, which is again famously known as Constantine's law. A structure is stable if cohesion is high and coupling is low, right? So that's why whenever you're designing your microservice architecture, you make sure you're as decoupled and as cohesive as possible. And if I move on, automation again, so this is the biggest piece. Okay, so this is again a biggest piece, the automation, the automated infrastructure, automated test and deployments. So these all why this is a critical piece, because you can build microservices, but if you don't build that pipeline, don't build that pipeline of integration and deployments, then you will be like exploring those paths every day, right? So there has to be a monotonous, boring pipelines which has to run every time the same way anytime we go and uh, check in your code to the source repository, right? So that boring pipeline has to come and run it and put your artifact to your production environment, right? Or your test environment for the testing. So if we don't create those automation infrastructure, right? So what will happen? You will be like every day exploring, okay, how to deploy that? Okay, this piece is missing, that piece is missing. So automation is great. Definitely helps to make that path monotonous, so that you don't have to worry how to deploy after writing your code every time. So, and then this is again a biggest piece which uh, you have to consider when you're designing your microservice architecture: failure. How to manage your failure, right? So you can manage your failure in a multiple way. It could be self-healing, where microservice. So the idea here is like microservice should be designed to tolerate the failure, right? It could be self-healing or it could be failovers, or like gracefully failing rather than you don't know why it failed, right? So you can fail and then your client can show a right message why the failure has happened. So that's all about handling the failures gracefully. Better error response can help to communicate the right message to the client, right? Better logging, monitoring, alerting capabilities, dashboards, things like that, which all comes under telemetry, helps to react to the production incidents to faster, right? So because most of the time we see, okay, some production incident happened and you are digging the code for 2 days to understand why that happened. So and these all can be avoided, minimized by your better logging, monitoring capabilities, so that you can respond to the incident faster, or sometime even you can take a pre-action to some of the to avoid some of the incidents. So again, this we have to think of anytime we are designing the microservices, we have to design for the failures. And this is again a big piece, which is again aligned to my talk, the journey, right? It has to be evolutionary architecture, right? So it's not like you just shut down the older system and on the new system uh, the next day, right? So it has to be evolutionary. So it has to be incremental change over time. So most of the popular pattern, if you read about, if I have to migrate from monolith to a microservices, all talks about the incremental changes over time, because it provides that capability to reverse also in case of failures in your new architecture, or the new infrastructure or a new system. It provides the capability to access if it's working for you or not, because a microservice is working for one organization, so that doesn't mean it will work for everyone. So this incremental change actually provides that ability to access, take a pause, access it how it's working for you. And again, this helps to change without the business disruption, because you write monolith, you write microservice, whatever you write, but the first priority is the business has to continue. So there should not be no business disruption. And sometimes there will be a lot of gray areas, right? And when we have to break out the big monolith and convert it to a microservice, or if it's a monolith is not there, try to understand the entire business and align with the microservice architecture, create those boundaries, bounded context, things like that. So those grays areas come. So sometimes we can start my macro, so a bigger piece you club together and start working, and then you learned it and then you made it micro. So that also could be your incremental part of your incremental changes, right? And I'm a big fan of go for a short-term wins, which creates a momentum rather than building everything. Everything is ready 100%, and then you go to production and see it. So we can think for something short, which can be achievable in near future, and you can go create those integrations, set up those pipelines, infra, go to the production, learn, refactor. So those actually gives you momentum also. So these are nothing but a way of doing how we can target to the incremental changes over time, right? And again, this is an open source India conference, and we all know to do this journey of building microservices, right? Technology has a big say to this. So open source technologies are now helping to play those key role in this journey, right? Be it your development phase or a build stage, test stage, deploy, telemetry analytics, everywhere now open source technologies are playing a key role, right? If you talk about the languages and frameworks, I think be it Java, Spring, or the or Node.js, everything, or beta unit testing, Mockito, things like that, library, starting code analyzer, security scans, right? And if I go to the build, you have a Jenkins, you have drone. So a lot of these things, which are actually an open source project, and these are actually helping in a great way to achieve all these building blocks, and all these building blocks are very much critical for any of the services to go, right, be it a microservice or monolith. And so and because it's a microservices, and you can have that independent deployable. So what can happen in one microservices, you can have different, entirely different technology stack. In another microservices, you can again go with a different technology stack, right? And but you have to go through this develop, build, test, deploy, telemetry analytics, AI, ML reporting, dashboards, telemetry. So there's Splunk is there, Grafana is there. So a lot of these technologies are playing a key role in this journey, right? And so why to go for microservices? So I talk about the monoliths, and I talk about the principles of microservices architecture while we have to consider while designing. But what gain microservices provide, if I have to talk about that, right? It reduce the time to market, because now with the independent deployable, what we have, we see one of the characteristics of microservices, reduce the coordination and the ability to push change to customer faster, right? And autonomous team. So entire ownership of the product aligned to a domain, and that means a smaller team helps to create a self-sufficient team, and decision making could be faster, right? So you have a smaller team, independent, deployable. So these are the two things which together works, right? The autonomous team, and which helps to reduce time to market, because some changes come and now you are the guy to take a decision what code has to be changed. No coordinations required with another service, because it's an independent deployable. You did a change, you have automated pipeline is set up, you pushed your change, and your code is passed through the automation test, integration test, everything, and then you boom, went to the production, right? So that's actually helped to reduce time to market. And the scalability. So scalability is pretty important, what I mentioned during monolith, right? Because now, let's say some microservices need higher resources than the other microservices. So you can only scale, or you can only concentrate how we can scale these microservices, because this needs a higher resource because of its uses, because of its criticality. So we can focus that. So you can only scale that independent deployable, right? And improve resiliency and robustness. So when I say resiliency and robustness, these are pretty close. But so when I say resilience, this is like improve the system's ability to avoid the outage, failed gracefully, faster recovery. So these are all resilience. So things which you have not anticipated, if that happens in your production environment, how resilient your system is to handle that. So that's all about. And you have a smaller microservice deployable. So that you can handle those better than your bigger process, right? And then the robustness, obviously. So the load balancer, the orchestration capability, which actually provides the robustness to your service, so that you'll be always highly available, uh, zero or low downtime and things like that. And the big piece is embrace the new technologies, right? As I mentioned, each microservice is its own deployable, and that's a big piece. I mean, you have to, if you have to take away anything from this course, right? Independent deployable. So that's a big piece, and that's why I'm keep on repeating that. Because it's independent deployable, you have a choice of technology for that microservice. So one microservice can be built with a Java and Postgres stack, and one could be built with a Node.js or a MongoDB stack, things like that, right? So that also a possibility to embrace the new technologies and see what's working for you. But what happens, the most of the organization, they try to standardize the tech stack, because sometimes even the more choices creates that inability to take decisions, right? So but yeah, but there is an option. You can always go with the different technologies. But yeah, there are a lot of benefits to go with microservices. So that doesn't mean it doesn't have a challenges, right? It brings a new challenges also. So because it's so microservices brings its new challenges. Why I'm saying, because there will be a lot of services, the more deployables, that means yes, there will be more pain, because that they have to connect between them via HTTP or the event bus and things like that. So now we have a dependency on the networks, right? And then it can add up to increase your latency and things like that, because now every piece has to connect over network. So that dependency we are creating over network. But yeah, and creating those bounded contexts, sometimes creating those uh, putting those lines of boundaries also will be a little challenging in a bigger piece, right? So these are the challenges, but with these challenges are actually trackable, or sorry, tackable, So it's not like you don't have a solution to those challenges, and there are a lot of solutions to those challenges. But yes, so when you're building a microservices, you have to be aware of those challenges, because the more services, yes, obviously, the more it will bring a little more challenges also over communicating between those services. So with this, this is my last slide almost. Because I'm talking about microservices, a modernization journey, and there is a famous pattern which has been put up by Martin Fowler sometime long back. I think it's a strangler fig application pattern, and this pattern also, if you try to analyze, right, it talks about journey. So what is the strangler fig application? If I just have to give a 1 minute brief. So strangler fig is nothing but it's a seeds. Figs are the seed in the upper branches of a tree, which start from there, and it gradually work their way down the tree until the root in the soil. So it starts from one of the branch of a tree, and then it come down when it hit the soil, and it becomes over the many years to they eventually become a tree, right? So if you see, it's a journey. So they started from that branch, and eventually they hit the soil, and then they grow into a fantastic and beautiful shaped tree, right? And when they grow to become a tree, they actually kill the tree that was their host. And if you think about this, this applies to our microservice architecture also, right? A new system will be dependent on old monolith application to start their journey, and till it matures and start handling all the business capability, and then finally we'll be shutting down our monolith and will be dependent on microservices, right? And that's exactly I'm talking about the journey. So with that, these are the books which you can read more to know about the microservices design patterns, how to move from monolith to microservices, things like that. So I'm inspired. This talk is mostly inspired for Martin Floor books and the Sam Newman books. Both are fantastic guys. They have created a lot of patterns which help me to understand the lot of the business microservices patterns. And thank you with saying that. So you can reach out to me, NC Patro, be it on LinkedIn, Twitter, or Medium, so or my blogs. So with that, thank you all for joining, and thank to the Open Source India organizer for giving me this opportunity.